So I picked up a batch of old FPGAs from Xilinx, and these are specifically a Spartan-3AN, and the part number I'm using is this one right here. It's a 256 ball BGA package, or they refer to it as an FTBGA. So it's a 17 millimeter by 17 millimeter. The pitch on the BGA is 1.0 millimeter, and it has nearly 200 I/O that I can use if I can get it up and running. I am using a kind of the same form factor I've been using on the previous boards I've been building. It's 100 millimeter squared. This way I can have it manufactured at JLC PCB, and there's kind of this 100 millimeter squared before you jump up to another, I'd say, cost tier. So that's what I'm trying to limit this to. It is an 8-layer board. I could have gone with 6 and probably gotten the job done, but 8 gives me a little bit more, I guess, room for running traces and power and things like that. And I'm learning a lot on the, doing this surface mount and BGA and routing and power distribution and all the things that go with this. So kind of continuing to build up some practice and time invested there, which has been, I think, really helpful for me. I am using these same 68-pin connectors I've used on previous boards, and so this will give me 68 pins that I can run over to another board, let's say for some peripherals or whatever I want to do with it. When I look at this FPGA, basically it's broken out into 4 banks. There's a bank 0, 1, 2, and 3, and I'm just going to send all the GPIO out through that connector, unless it's being used for something else on the board here. There are some input-only pins. Instead of input-output, they're input-only, and I have those just going to these two headers here. I don't know if I'll even use those, but they are available if I want to do something with them. As far as power on this, I am coming in with a 5 volt. I'll indicate that I've got a 5 volt. I have a pair of buck regulators to get me my 3.3 and my 1.2 volt, and I have some LED indicators just to show me that I have those rails. So I have 3 indicators showing me that I have these 3 rails up and running. There is a mode select. There's 3 pins to potentially connect to ground, I believe, to select mode. So I've got 6 pins here, basically a mode 0, 1, and 2 pin, and the option to basically straddle that to ground. I think that has to do with whether I'm going to boot to the internal flash, or on the back of this I have external flash that I can use. So I believe that's what the mode is for. Now I need to read up on that. I have a lot of reading actually to do in general on this FPGA. The couple of documents that I'm using, I guess for reference, let me flip over to those, are first and foremost the data sheet. So that's 120 some pages. And then there is also a configuration user guide that's another 350-ish pages. So 500 pages of content that I need to work my way through. So far I've just kind of been skimming it very, very quickly, but I need to take time and really dig into that. And as I do that, I might learn that maybe I misunderstood some of these, for example, mode or anything else I might learn as I go through that. So I know this is going to change before I actually order it, but this is kind of where it sits right now. Other things to point out, I did put an oscillator on the top side here, so a little surface mount oscillator. Maybe I'll put a 50 megahertz oscillator on there as an example. I also put an oscillator on the back, and this would be if I want to drive VGA. This will give me the 25.175 megahertz oscillator I want to use for VGA. Knowing that I probably could use PLL or something else like that off of this oscillator to get me my VGA, but I'm just going to have this separate one just for ease, and I have a whole bunch of these oscillators down here on the back side, these little surface mount ones, so I'll just use one of those there. I have my programming header. I did put in a 1.27 millimeter header with the JTAG signals. I know that's not the standard physical format, but I'm not worried about that. I can put together a little adapter that goes from this to the standard JTAG connector if I do end up using JTAG at some point. Up to this point, I haven't really done much with that. I've mostly been using headers like this to do the programming. But as I get deeper into this, I'm sure that JTAG will come in handy at some point. On the back side, maybe just taking a look, again, I had that oscillator down here. Here's my commodity SPI flash. So I'll use the same flash I've been using in the last couple of boards that I built for my ICE 40 builds. And that should be fine for this FPGA. It does seem like there is a Spartan-3 and then there's a 3AN. And the AN can use the commodity flash. And it seems like from what I'm reading, the Spartan-3, the slightly older one, requires a little bit more specialized type of flash IC. Now on here, I did put a little effort into just trying to get this covered with capacitors in an effective way. So you can see there's some larger capacitors around the corners here. I have some 0603s that surround the FPGA. And then I've actually straddled the 1.2 and 3.3 pins that are near a ground with ground, so that I can basically get as close of a connection to those pins as possible. So these are 0402 capacitors. So that will be fun to try to solder those by hand, but I'm going to give it a shot. That would give me just really some really as close as it can get for me as far as getting those capacitors to those power rails. So I'm hoping between all of those, and worst case, if I can't solder these 0402s, I think what's around here should be sufficient, but it'll be nice if I can also get these on there. And that's probably the highlights of this board. And maybe I'll jump to the schematic just for a minute or two. If I run through this rapidly, I'm bringing in my 5 volt into this power connector. I have an indicator to show that I have 5 volt. I have one regulator that'll take me to a 3.3, another regulator that'll take me to my 1.2. They have capacitors on those rails, along with basically coming up here and having an LED and a resistor going through a transistor, so that if I get my 3.3 volt, I can turn on this LED using the 5 volt as the supply for that LED. Same with the 1.2. Get my 1.2 signal running, this LED will light up. Now, you'll notice there is nothing here to do sequencing. The research I've done on this Spartan-3 is that there is no requirement for sequencing unless you have a certain type of flash that may need some delays in how that works. But I don't think that's going to be the case for what I'm doing. And the FPGA itself doesn't appear to be super fussy as far as the sequencing of my 3.3 and my 1.2 rails. But I might find that that's not the case as I read through the documentation in more detail. If any of you have anything to suggest other than that, let me know. But I did find a post over here on Xilinx.com, and someone was kind of asking, is there a power on sequencing requirement? Now, this question was for a 3 and 3E. Now, I have a 3AN, and my assumption is that these are all kind of being treated the same. And the answer is, that no, there's no power on sequencing. But they do talk about different, there's a 12-inch silicon and an 8-inch. I'm assuming they're talking the wafer and different runs, manufacturing runs or something, how they're producing this. But my takeaway from this, which could be wrong, is that I don't have any power on sequencing requirement for this FPGA. If I keep going, I have my 2 oscillators, again, the top side one and the bottom side one. I do have those connected to signals on the FPGA that are global clock lines, so I think I should be okay there. I have my programming header that I can plug into that gets me to my SPI flash on the back side. Again, I'm using the same SPI flash as my last couple of ICE 40 projects. And then if I work my way down, lots of power. And for now, I'm just really hard setting all of my rails to, all the I/O ports to 3.3 volt. That's what I'm going to really be working with exclusively for now. Maybe a future version, I'll make this selectable, but I want to kind of start with step 1, just get the basic FPGA working. And then, 3.3 is what's probably common for the stuff I'm going to be working with. So I'm not worrying about other voltages yet. I'm not going to try to do anything like DRAM or anything that I think should be super fussy about lower voltages or length matching, things like that on my traces. I'm going to try to do a little bit of length matching, but intention is not to run DRAM or anything like that yet on this. A lot of capacitors over to the right for my 1.2, the 3.3. And then here's the main FPGA itself. So this is giving me all of my signals. I've got an indicator over here for done. And where is that at on my PCB? Back over here. And so that indicator is right here by the programming port. So that is my done indicator. And then you can see here I've got my mode signals, CSOB or CSO, MOSI. And I can come over here. I got my clock, my data in. Those are all going over to that programming port. Here's the header for my JTAG. And then I come down here and I'm basically taking all those signals and breaking them up so that I go to one of the 68-pin connectors. I try to grab all of the signals from that bank. And it seems like as I'm going through this, the naming convention is this last number, the 0, says that this is bank 0. These are all the bank 3s. And then I come over here and I've got bank 2. And then I have bank 1. And I'm using the same format of this layout of this connector as I did on my ICE40 board, the 256 BGA version. So I should be able to take the same cards, whether it's a static RAM card or a video DAC or some other type of thing, and plug it into this and not have to reproduce those cards. They should just be able to plug in and use them. And for some of these banks, there aren't enough pins to fill up this connector, so it just means I've got some empty pins on the connectors, which is perfectly fine. So then I tried to lay these out kind of in an order that is easy to understand. I got all these, the P0s on the left and the N0s on the right. And then here are some of those IP input only signals. And I don't know much about those, but I just separated those for now. I could easily just run those out through these connectors if I wanted to, but I haven't done that. Here's another one of those, IP2. So I suppose I could take these signals and run them out through the bank 0, and I'm guessing these are bank 2. That's just a guess. I haven't looked too deep into that. And that's really it. If I go over to the PCB version, this is what it's looking like. I could pull up my stackup real quick. I have my bottom signal layer, ground plane, signal layer, ground plane, pure 3.3 volt plane, and then signal, ground, signal. As far as the 1.2 voltage, I'm just doing copper fill on the signal layers where I need to get 1.2 distributed. And that all seems to be okay. If I zoom into my fan out, obviously I did manual routing on all of this, and that's been good practice. And one comment, I'm coming from the ICE40 BGA, which was a 0.08 millimeter. This is a 1 millimeter, and that slight difference just feels like a huge difference. It just feels like I have so much more room here. I can much more easily fit, a pair of traces between every one of these pads. So getting this, out and routed, you can see for the most part, I'm really just using 3 layers for signal. There's a couple of exceptions. You'll see some of this here. If I go to, this layer, let's see, right here, you can see I've got some of those, a little bit messy on some of them. That was kind of my last of all the signals I had to get routed, and those were ones that I was less concerned about or just simply ran out of space otherwise. But if I go to my top layer, there's all my top layer. Here's my bottom layer, the blue. And then I have an inner layer that looks like that and another inner layer that looks like that. So this is the messiest one of them, but I think for now that's fine. And if I put more time and energy to this, I'm sure I can improve that. But I think for my purposes at this point, this is fine. Again, you can see all the capacitors around. You can see how I've come in here and put a capacitor on the bottom side that straddles the 1.2 to ground or 3.3 to ground. And so I've got 4 of those 3.3s So quantity 4 of the 3.3 volt to ground. These are all 1.2s to ground for decoupling capacitors. So if I'm going through this and you've got thoughts, there's, I'm sure, signals back on this, on the schematic that I don't maybe understand yet or need to do something with, but you can see which ones I've called out up to this point, I guess. There's a prog signal. I need to figure out if I need to do anything with that. Prog B, this one right here. I did just run it to a small pin header for now so that if I need to run a little bodge wire and connect something up later, I can do that. And are there any other critical signals that I need to make sure I get run out to a header? I think all of the signals, I don't know if I have any signals that aren't going out to something that I could later solder to. Obviously, I've got a lot of these that will connect out to these pins, and I can always solder a bodge wire on the bottom side of the board to get to one of those if I need to. So I'm hoping that there's not any BGA pins or pads that are not exposed somewhere somehow. And a lot of these here too are with a via. So I did via and pad. And that means I could also solder on, I suppose, to the bottom side if I absolutely had to, although that might be a little tricky. Probably not even possible, actually, because these will get covered. So maybe scratch that idea. Or maybe you can't get to those solder-wise unless I left them exposed, which I don't know if that would be a good thing to do or not. So if you've got any advice, if you've learned something in the past and you see me repeating a challenge that you've run into, let me know. But I'll read through the documentation. I'll come back and keep tweaking this and then see if I can maybe order this up in, I don't know, maybe in a few weeks. I want to do a couple of things. I want to test these buck regulators on my ICE 40. This latest board that's coming in will use these. And if I have issues with those, then I need to come back to this PCB and wipe those out and put something else in their place. Other than that, I just have to go through the documentation, make sure I'm not missing something that's going to really cause me a lot of pain later. I think as far as the programming, some of the bigger concerns maybe would be, am I going to be able to program the flash correctly? Is it going to be able to boot from that flash correctly? I think I have things accounted for that, but there's a chance I could be mistaken. Maybe one final parting comment on this video. It does seem like there are some neat little dev boards out there. There's maybe some older Xilinx board, or maybe there's a couple different boards. I know there's one for sure that uses the Spartan-3. And then I did see there's a pretty handy little Spartan-3AN dev board out there, just a little breadboardable board, super simple looking board. So I did order one of those just to kind of check it out and see what that looks like. And I do have incoming one of the Xilinx. I did find one of the old Xilinx Spartan-3 dev boards on eBay for a small fee. So I did order up one of those to maybe just learn from those too. I did post a community post a while back just showing that I had picked up some of these and also some of these other Xilinx, what are they, XC5215s. And those are, I think, even older FPGAs, and it's a QFN package. No, sorry, a QFP package. Reading up on those, pretty interestingly, they appear to be a 5-volt FPGA, so 5-volt I/O, and I got to double check that, but I think that's what I was reading. So that might be really interesting on some of the retro build stuff that I do. If I have an FPGA, the challenge with those is, can I program them easily or not, and what do they take for special flash or anything like that. But if I can get those working, those might be a really interesting option on some of the older 5-volt system stuff that I've been doing. That's where I'm at. So good enough on this one for now. I'll keep doing some work on it, looking for any feedback, thoughts any of you might have, and try to get this ordered up and experiment with this as the weeks go by. So thanks for watching.